Hey kids, time to move on from first order differential equations to second order differential equations. But not really. What we're going to do, you're used to by now of manipulating and substituting and doing all kinds of calisthenics to try to manipulate equations into forms that we recognize and can deal with. So this method, called the reduction of order, is exactly what it sounds like. I'm going to try to reduce, if I have a second order differential equation, I'm going to try to reduce it to a first order, because we've figured out, we do know from chapter 2 how to deal with a lot of different first order differential equations. So we dealt with in the first sections too of chapter 3 how to deal with second order differential equations when we had constant coefficients. So I didn't need to bother to bringing out the reduction of order when I had just constants in front of y double prime, y prime, and y. But now I'm going to have non-constants here. Again, if I have a non-constant in front of y double prime, I can just divide through, right? I am homogeneous. And we'll see that when I'm not homogeneous, if I have another function in here, it just affects the type of first order that I'm going to fit into. Again, finding solutions can be a little challenging when these are constants instead of when these are not constants, when they're functions. So this is one method to try. My goal, right? I'm a big Star Wars nerd. My goal, so I can't, when someone says first order, I can't help but think of good old Kylo Ren there. My goal is to take this second order differential equation and manipulate it into looking like a first order. Now remember, a first order differential equation, looked like this. Y prime plus p of x or p of t, y is equal to 0, right? You had a y prime and a y itself. Here I have a y prime and a y double prime and a prime and a y. I need to be able to manipulate this equation so that I only have 2 terms. That's my goal. Now, the other caveat to this is the method of reduction of order only works if you've got one of the solutions. So if I know one solution and I'm trying to get a fundamental set, in other words, I'm trying to get the second solution, if somebody gives me the first solution, I can use it to get one of the other solutions. So here's my steps. There's going to be about 8 of them. Somebody gives you y1 is one of the solutions of a given differential equation. I'm going to say my overall solution, y. This is my overall solution, right? My general solution is some function v times my y1. And my goal is going to be to try to find that v. So step 2, find the first derivative. Now this is a product, so you need to find the first derivative with the product rule, right? Y prime is the derivative of v times the function y plus that function v times the derivative of the y1, which is y prime. Then I need to find the second derivative. Maybe you see where we're going with this, right? I've got y prime, and y double prime. So now I have 2 product rules here, right, that I need to do. So the derivative of v is v prime, leave y1 alone, plus leave v prime alone, take the derivative of y1. So that's the first product rule. And here's the second product rule. Take the derivative of v, multiply it times y prime, plus leave v alone, multiply it by the derivative of y prime, and I get y double prime. You don't really want to have to do this each time. There is a pretty nice pattern with this. Do you see it already? Right? These two, there's 2 that are doubled up. So the reason I'm doing this formula in general instead of doing a specific example is to show you this pattern. Why do I have two of these? Now I'm going to take y double prime, y prime, and y. Now remember, it's all in terms of that first solution that I was given, that y sub 1. And I'm going to plug back into my original second order differential equation. Here, this is the original with non-constant coefficients. Here's y double prime. I dropped the of x's. P times y prime and q times y. That's what I got from my previous slide. Everybody equal to 0. Now I want you to collect like terms. So notice I tried to highlight in different colors, right? I have one v double prime term, but I have a v prime term here. I have a v prime term here that's multiplied times p, right? Then I also have a v term here, a v term here, and a v term here. Remember, this v term is multiplied by q, this v term is multiplied by p. So I'm going to collect like terms. I only have one v double prime. Here was my v prime. Remember, my v prime are my yellow terms, 2v prime y sub 1, and p times y sub 1 times v prime. And I just factored them out so that I had just a v prime there. And then I collected everybody that had just a v in it, right? So I have y double prime, p y prime, q y sub 1. I collected all of those. So I still have right now a second order differential equation, right? And it looks uglier than what I had pretty much. V double prime, V prime, and V. But wait for it. Do you see what happens here in that box? I have y sub 1 plugged into the original differential equation, right? I have y sub 1 plugged in here, y double prime of 1, p times y prime of y sub 1, plus q times my solution y1. What is true? If I know that y sub 1 is the solution, when you plug in, what are you going to get? Plug in, you've done this, what do you get? 0, honey. Bye. That whole term that's in front of v to the first goes away. What? This whole term in front of the v is equal to 0. So therefore, this term times v is equal to 0, which means after I collected like terms and realized what was happening, I now only have a 2-term equation. That's my reduction of order formula. The given solution times the second derivative of v plus, now remember what v was defined to be, 2y first derivative of the given solution plus p times the given solution, all of that times v prime is equal to 0. Whoa. Who thinks of this stuff? Abel did. So now that I only have 2 terms equal to 0, I'm going to wink, think of this like a first order. I'm going to pretend that I have, right? I'm going to have some function. I'm going to pretend this is times v prime plus, I don't even want to call that. I'm going to have some function f v prime plus some other function g times v is equal to 0. And I'm going to solve that. I'm going to solve that first order wink wink differential equation, but I'm going to solve it for, instead of normally we were solving our first order differential equations for y. This term here, I'm going to solve it for v prime. And I'm going to use the integrating factor method because it is a linear differential first order wink wink differential equation, where this expression here, I'm going to have to find my integrating factor, and I'm going to solve for v prime. But remember, I don't want v prime. What I'm after is v. So then I have to integrate v prime to get my v. And then recall from step 1, we defined our overall solution to be v times y1. So take this v, plug it in, and you're going to get your general solution. Oh my gosh, this sounds so amazing, doesn't it? Let's try one. All right, so keep these steps in mind. So, given a solution, and here is one solution to this differential equation. You could check it, couldn't you? Check. The second derivative of x is 0, right? So x squared times 0 minus 4x times the first derivative of x is 1 plus 4 times y, which is x. Is that equal to 0? 0 minus 4x plus, yep, it is. So x is one solution to this differential equation. Let's use the reduction of order method to find the second. Then we're going to write our general solution. So we are going to say, first, let our general solution be y is equal to some v times our original. I found the first derivative of v times x plus v times the derivative of x, which is just 1. Found the second derivative. Now remember, in here, there's really two product rules in here. Right, I had to do the product rule twice. Well, I guess not really, because this was just a v. So I was doing v double prime times x plus v prime times the derivative of x, which is 1, plus the derivative of v prime, of v, which is just v prime, which is where I got the two v primes from. Then I substituted back into this original. So I substituted in for y double prime. I substituted in for y prime. And I substituted in for y. Okay, that's what I did. Now, at this point, remember, next in the general proof, right, when I was doing this just in the abstract, I collected like terms and we recognized the initial solution piece that was equal to 0. You don't have to go through that because I've actually got a value. So if you notice here, if you actually just distribute, what happens? Right? You get x, whoops. You get x cubed v double prime. You get 2x squared v prime minus 4x squared v prime minus 4vx plus 4vx by. That should always happen. Your v to the first terms should cancel out, all because of that original solution. That if that doesn't happen at this step, you've done something wrong. Okay? And again, the reason they cancel out is, I did that kind of in the proof. The reason they cancel out is because you will have plugged in the first solution. And the first solution is equal to 0, and we check that. Now, wink, wink, I have two terms. Yes, I know it is a second derivative and a first derivative, homogeneous, but I'm going to wink, pretend that this is a first order. First order linear differential equation. And I'm going to use the integrating factor method on it. And the integrating factor method means I'm going to divide by x cubed and then find my integrating factor, which will be the new coefficient of v prime. Right, so divide everybody or multiply by x to the negative 3. Now I'm going to look for my integrating factor. Right, this big wink here on this whole page. Don't get this confused with the Wronskian formula for E, right? The negative that's out here is because of this negative. I'm going to assume x is greater than 0, so I can drop my absolute value. There's my integrating factor. So I'm going to multiply everybody by it so that I recognize the product rule in reverse, right? This is the product rule. What is the product rule of? X to the negative 2 times v prime. Take a double check, make sure that's right. What would the derivative of x to the negative 2 v prime be? What would be the derivative of v prime? V double prime times x to the negative 2. And v prime times the derivative of x to the negative 2, which is negative 2x to the negative 3. So that's what I have there. Take the derivative, antiderivative of both sides. And then isolate v prime, because remember v prime is what I'm after. Now what? I was after v prime, but now what do I want? Remember my overall goal was to get what? V, right? So I'm going to integrate v prime to get v. So v is equal to c1 x cubed over 3 plus c2, a different constant. There's my v. Now remember, once I have v, I'm going to plug it in. Remember from the beginning, we let y equals v times our x, where x was the given first solution. So I'm going to plug it in here times my first solution, and I'm going to distribute. I'm going to wrap up this 1/3 of a constant is still a constant. And there's my general solution. OMG. Remember, we already had found this. We were given this. We used the reduction of order formula to come up with x to the 4th. Wink, wink.